Dear students, let us continue the third module. The next topic which we are going to study in this module is memory allocation, and second topic is environment variables. So let us see the different memory allocation we have in Unix operating system is malloc, calloc and realloc. You must have studied in your data structure also. So the thing here we are studying with respect to Unix operating system. So why they all are dynamic memory allocation. Based on the requirement, memory can be allocated. Now here see malloc is it malloc which allocates a specified number of bytes of memory. How many bytes of memory is required, malloc will allocate. The initial value of memory is indeterminate. That initially we don't know how many bytes of memory is required. So we don't allocate initially. Based on the requirement, dynamically we can allocate. Next memory allocation function is calloc. Calloc which allocates space for a specified number of objects of a specified size. It allocates the space to the number to some number of objects with specified size. The space is initialized to all 0 bits. Initially all the spaces of objects will be initialized with 0 bits. Next is realloc. Realloc. So realloc which increases or decreases the size of previously allocated memory. Suppose previously 50 MB of memory is allocated to a process P. Now that process P during runtime it came to know that it doesn't need 50 MB. So using realloc we can decrease the size of memory allocated to process, or based on requirement we can also increase the size of memory provided to a process based on its requirements. So prototype for all the three functions is void star malloc size underscore t size. Here only one variable is there. Next one void star calloc size underscore t in object comma size underscore t size. Next is void star realloc void star ptr comma size underscore t new size. So all the three return null, non-null pointer if okay, and null on error. They can return null on error, or it can return non-null pointer if, because they all are pointers, they are pointing to some objects. So on return what they will return, they will return if they are successfully allocated the memory, then they will return non-null pointer. If some error has occurred, then it will return a null pointer. Next memory allocation is free function. So the function free causes the space pointed to by pointer to be deallocated. So free function, what does it do? It make the spaces free allocated by some process. So this free space is usually put into a pool of available memory and can be allocated into a later call to one of the three alloc functions. So after freeing the space by free function, the memory which has been freed, they will be added to the available memory, and again this memory can be allocated using calloc, malloc and realloc. The realloc function lets us increase or decrease the size of previously allocated area. Yeah, it using realloc we can increase or decrease the allocated area. For example, if we allocate room for 512 elements in an array and that we fill in at runtime, but find that we need room for 512 more than 512 elements, we can call realloc. So if we need that space more than 512 elements, then we can call the realloc. And if there is room beyond the end of the existing region for the requested space, then realloc doesn't have to move anything. It simply allocates the additional area at the end and returns the same pointer that we passed it. So at the end of existing region, if some more spaces are available, then kernel will call the realloc and it will allocates the additional area at the end and returns the same pointer that we passed it. But if there is not room at the end of existing region, realloc allocates another area that is large enough, copies the existing 512 element array to the new area. Suppose uh, we have found some empty area, but that is not enough for 512 elements. So kernel what it will do, or realloc will find the next region which is long enough for 512 element array accommodation. Next topic is environment variable. The environment string are usually of the form name equal to value type. Name equal to value type, and wherever you see that is called environment variable. The Unix kernel never looks at these things. Their interpretation is up to the various applications. The Unix kernel never looks the environment variable, and the shell, for example, use numerous environment variable. Some such as home, user are set automatically at login, and others are for use to set. So once the system is started, then these environment variables like home, users will be automatically set seeing the login. We normally set environment variables in a shell startup file to control the shell's action. The function that we can use to set and fetch values from the variables are set env, put env, and get env. So using these three functions, we can handle the environment variables. The prototype of all the three is char star get env constant char star name. Here get env is to get the environment variable, and here const char star name is nothing but the this is the second argument. A returns pointer to value associated with name null if not found. It will return null pointer. And note that this information returns a pointer to the value of a name equal to null starting, name equal to value starting. We should always use get env to fetch a specific value from the environment instead of accessing environment directly. In addition to fetching the values of an environment variable, sometimes may want to set